tonight.
Hi, my name is MIRZA QISTINA binti MIZAMAN with metric numbers 2020829168.
AMIRUL HAZIQ bin Muhammad NAZRI, metric number 2020-478854.
Hello, my name is AFIQ ASHRAF bin RAHIM, number metric 2020-458218.
Our program code is EC110.
We made this video for our course code MAT183.
And our course is PEC 1101B.
So in this video, we're going to talk about application of integration. So what is application of integration that we're going to talk about? Is about introduction, problem solution, problem statement, and conclusion. The problem solution and problem statement for each subtopic in the application of integration is. So for introduction, we're going to talk about the history of integration. So what is integration? Integration is the inverse of differentiation of algebraic and trigonometric expression involving brackets and power. This is indicated by the integral sign, which you can see as in like that kind of sign, which usually call it as indefinite integral of the function. So when the integration was found, it was found around 1635 by Cavalieri, which is an Italian mathematician. You can see his picture in there. Why it was found, why Cavalieri very enthused want to found the integration is because he want to solve problem in mathematics, in physics, involving area of arbitrary shape and the length of curve and the volume of solids, among others. So I'm going to introduce you guys about area between two curves. How to do area between two curves. So today I'm going to teach you guys how to find the area under the graph using integration method. So this is the question we got. We need to find R, which is being shaded. This is the x equals to 2, y, this one is y equals to x2 plus 1. So how to find the area of the R? We need to use this formula. Okay, you guys can see it. Okay, so the formula to find this, we need to find Cx, which is the area that we shaded, by minus the fx and gx. Okay, so the solution for this question is like this. Cx minus equals to yt minus yb. Yt is the y equals to x2 plus 1, while yb is equals to 0 because we doesn't know the y for the, because it is in y equals to 0, so equal to 0 itself. Okay, so when we minus it, we get x2 plus 1. So because we doesn't know the dx, because that we need to use this kind of method. We doesn't know this, we need to use this. Okay, so after we know the cx, we just need to substitute it. So we come to x2 plus 1 to 0. Where come the 2 and 0? It come from here, 0 and 2. If you guys can see, 0 and 2, so 2 minus 0. So you put the 2 into the 3 into this formula and minus with 0, and we got it 14 over 3 units squared. Why squared? Because it is area. So that's how you use integration to find area under the graph.
Okay, so for the topic volume solid of revolution, I will show you how to solve using two methods, which is the first one is volume by this method and second one volumes by Walsh's method. Okay, so this is the question. This is as question, and then the question say revolve about the line x equals y. So the formula, we need to use the middle one because the x-axis is in front of y-axis. Okay, so we use this middle formula. Okay, let's see how to solve. Firstly, we change this equation y to x. Okay, so it will be x equals 5 minus y square. After that, we minus this to x1. It will be x square 4 minus y square. Using the formula, we can solve it. Remember, for x-axis, we use y. Next, we solve this equation. Because this integration, we minus to 0. Why 0? Because this is 0, so we times all this, it will be 0. Next, using the calculator, we can get the answer, which is 256 over 15. Right. So this is the question for the washes method. Basically, this method is same like this method, but only the formula a little bit different. Okay, so this is the formula for that question. Exactly, we use the first formula. So OR is the red line and IR is the blue line, and the formula is pi integrate AB square OR square minus IR square x. So for this equation, we change to y. It will be 2x plus 3 equals y. This is OR because the line is maximum, and then it is IR. Okay, so this is the solution for this question. As you can see, it's same like this method. We just integrate plus, minus, and times, and we can get this answer, which is 1088x over 15 units.
So I will continue with the volume by cylindrical shell. And this is the topic that I will explain to you, which is case 1 and case 2. It's a very similar, but it have a little bit difference. Okay, I will show you about the case 1 and case 2, which is y axis for the case 1 and x axis for the case 2. The main formula is quite same, but the difference at the BA and DC, which is here. AB is here, which is in the vertical, which is in the x line, and y line is DC. So what is for the case 1, if the k at the left of the shaded area, we need to use this formula. But if the shaded area is at the right of the k at the right of the shaded area, we need to use this formula. Yes, you see, it's still the same. And for these two, is quite similar. As I can say, if the k at the up, we need to use the formula. K is the up shaded area, and if it down, we need to use this formula too. Alright, so I hope that you can understand what I said. So we move to the question set so that you all will be more understand. Okay, the question is, find the value of the solid reformed by revolving the region and bounded by the curve of y x equal to x squared plus 1, x equal to 0, x equal to 3, and x axis about y axis. So we need to use this formula because the k at the left of the shaded area, we need to use this. So at y axis, which is case 1. From this, we need to get in all the value, and we will get this, the value of all the variable. From this, we need to multiply it and get x, and x squared plus 1 dx, and we will get this. From this, we need to multiply it and get x cubed plus x. From this, we need to integrate the values. After that, we will get this. From this, we need to get b and a value into the x, which is we will get 99 over 4 minus 0 divided by 2 pi, and the answer is 99 over 2 pi units cubed. So I hope that you all will understand what is my explanation. Thank you. So for the conclusion is, I hope that the explanation that we all as a team explain to you, especially about the application of integration, I hope that you will understand it clearly what we're trying to explain to you all. With calculus is concerned about theoretical and application of integral, and calculus also care for so many aspects, which is rate of change, slope of tangent lines, and velocity. Integral calculus deal with a total size and values such as length, area, and volumes. The two branches are connected by fundamental theorem of calculus, which show how to definite integral is calculated by antiderivative. So it shows that application of integration or a calculus is very important for our lives. So this is the reference that we use for doing this assignment. It seems that we are at the end of our presentation. Me and my team want to say thank you very much.